inform at least, and this should not be repeated. Okay,
Yes,
okay,
sir.
fine. So what I was telling you is a data word will be there. On that, certain processing will be done, and a parity bit or redundant bit will be generated. So data word along with the redundant bit will be called as a code word. It will be transmitted via an unreliable transmission path. This is what your unreliable transmission path. And then if this A3, A2, A1, A0, now it will be called as B3, B2, B1, B0. Your this R0 will now become here Q0. And if this value, it is not, it is like very much possible that there could be a change in the data, and another possibility is there is no change in the data itself. Both things can happen. Now, when this B3, B2, B4, B1, and B0, it will be given to a logical decision. That means all the data will be available here, but it will not proceed to the receiver side. It will not go to the receiver side directly. It will wait for a decision to come, and that is why this block is called as a decision logic. What the decision would be about? If B3, B2, B1, B0 is appearing here, the decision would be whether B3, B2, B1, B0 is same as A3, A2, A1, A0. If it is exactly same, then this data can be forwarded to the receiver directly, and it will be referred as A0, A1, A2, and A3, which is same as that at the receiver side. So whatever is happening, whatever the data available at the receiver side, same will be available at the transmitter side. But if at all any kind of change occur, then it will be discarded. Now, who is going to make the decision about whether the given data has any kind of error or it does not have any kind of error? So that all data will be passed on to a circuit called as a checker. So this checker circuit will have 5 bits available as an input bits, and what it will do, it will proceed, it will process on 4 bits and check for its parity, which is exactly, or check done do an operation which is done at the generator, and the result of which, if it matches with the Q0 value, and then only the syndrome will be cleared as 1 or 0. The syndrome, that is nothing but output of a checker, which may be a positive or negative. That means whether the error has take place or error does not take place. If error take place, that means discard value will become 0, and if error is not present, then the data will be forwarded to the receiver side. So the syndrome will be the result of a checker, and what a checker does, it processes on the data the way it is done at the generator. आता जर कन्फ्यूज होत असेल तर हे एक एक्झाम्पल बघूयात आपण स्क्रीनवरती. आपण आता असं इमॅजिन करा, या या एक्झाम्पल मध्ये की 4 बिट येत आहेत, ते जनरेटरकडे जात आहेत, आणि त्या 4 बिटचे 5 बिट होत आहेत, ज्यातलं 5वं बिट ह्या जनरेटरचं आउटपुट आहे. मग आता इथं बघा, here you have 4 bits, 1 0 1 1. So on this 4 bit, the first 4 bit here on the like, look for this example I am taking. So 1 0 1 1 is your first is your data word. Here at the code word you can see 1 0 1 1 is present, but this additional 1 is added, which is nothing but your redundant bit. And how it has been added? Odd parity operation is performed, where we will count number of ones. So here we have 1, here 2, and here it is 3. So total number of ones present are 3. As 3 is an odd number, we added here 1. So altogether the parity bit become 1. Just take example just above to it. Here it is 1 0 1 0. That means 2 number of ones is there. So the number of ones is equal to 2. That means even number. So obviously output will become 0. So as we are going for odd parity, the redundant bit here come 1. So try to understand here that same, try to link that example here. So the values will appear here 1 0 1 1, and redundant bit value will become now okay, just somebody inform from girls side to Miss Sonali Vargar that I have denied the intake, and she will be marked absent because she is again, now she is trying to enter after 40 minutes of class. So for this generator, all those 4 bits, it will be processed and output of the redundant bit will be calculated. So 1011, now output here is 1. Same data will be forwarded here. It may have error, it may not have error, and then that will be checked at a checker side. So say for example, it does not have any kind of error. Then what will appear? Here? You can see if no error occur, the receiver code word will be 1011 and 1, which is as the data which we have transmitted. So the syndrome will become 0 because everything matches. Then syndrome value will become 0, and the data word will be created, that is 1011, because the last bit will be discarded. This bit 1 here will be discarded because that was not part of data, that was only the redundant bit. So it will be discarded, only 1011 will be forwarded. Then this data 1011 will be created without any kind of error, and here the data word is generated successfully, which is go under the accept method. Now, if 1 bit error changes A1, म्हणजे इथं A1 मध्ये समजा change झाला. How we have checked A1? Acha, from right side second bit means if this value here change 1001, if data appear like this, then the receiver code word is 10011. The syndrome is 1. Why syndrome will become 1? Because it will check initial 4 bits. Those will be 1001. So how many ones will be there in first 4 bits? It will be 2. So redundant bit would have been equal to, even that means 0, but here it is 1. That means error has occurred. It will be received by the it will be detected by the receiver, and it will ensure that syndrome value will become 1. And when syndrome is 1, no data word is created. That means data would be discarded. So if 1 bit error changes R0, then R0 if it changes, then also we have 10. That means the last value. The redundant bit itself change. The data, like for example, out of this 5 bit of code word, out of this 5 bit of code word, if anything changes, even data will remain as it is. But if redundant bit changes, then also it will be considered as an error and it will be discarded. Data will be discarded. That is what is shown in this example. If 1 bit error has changes R0 value, code word receive will be 1011, and last thing is 0. But total number of ones here are 3. So it should have been 1, but it is 0. So syndrome will become 1 and data will be no data is created. That means data will be discarded. So these are the few cases I am trying to show it to you. Now, if error occur in R0 and then A3, if 2-bit error will occur, then unfortunately the error will not be detected. If 2-bit error will occur, error will not be detected. The wrong value of the syndrome will be selected, and there would be a problem with the entire mechanism for this linear block code. If 3-bit error occur, then say for example A3, A2 and A1, so which we have seen here, A3, A2, A1 is if these 3 bits change. So out of 1011, that means first 3 bit will change. So 01011, 01011. This will be the data. If all 3 bits change, then now if we can see 0101. So total number of ones are 2. So parity should not be 1, but the parity here is 1. That means error will be detected and syndrome will become 1. Now what conclusion we can derive out of this is, if we are using odd parity here, then not only 1 error is detected, but all the odd number of errors will also be detected. That means if we are using 7 bit of data and odd parity if we are using, then if 1 error occur, it will be detected. 3 errors occur, it will be detected. 5 errors occur, it will be detected. 7 error occurs, it will be detected for sure, 100%. But if even number of errors occur, those will not be detected. and that was the problem with the simple parity check, and that is why it is not been practically used or implemented, because it does not give you guarantee of uh, the error detection for all possible combination. It will give you guarantee for a simple error check can detect an odd number of errors. So या parity check मध्ये फक्त odd number of errors चेक करता येतील. मग ती 1 असेल, 3 असेल, 5 असेल, 7 असेल, एवढ्याच एरर चेक करता येतील. Even number of errors जर झाल्या, those will not be detected, and that would be the biggest problem with this simple parity check. Now, is it clear to you all? Somebody just give me a feedback. Is it clear, or you seek some input?
Clear, sir.
It is clear, right? Okay. Now there is one more method. We call it as a two-dimensional parity check. Now earlier what we did here is it was only a single dimension parity check. Now let us go for a two-dimensional parity check. It is now, if you recall, the subject which I taught you, ECAD, in that we have seen half wave rectifier, then we have seen full wave center tap rectifier, and then at last we have seen full wave bridge rectifier, because we have to praise that full wave bridge rectifier. So we start finding problems with earlier rectifiers. इथे तसंच आहे. आपल्याला कौतुक कोणाचं करायचं आहे? आपल्याला सीआरसीचं कौतुक करायचं आहे. ही जी आहे याला आपण म्हणतो सायक्लिक रिडंडन्सी मेथड और सायक्लिक रिडंडन्सी चेकसम, ज्याला आपण म्हणतो सीआरसी. ही एरर डिटेक्शन मेथड आहे जी खूप चांगली आहे, पण तिथपर्यंत पोहोचायच्या आधी आपल्याला 2-4 मेथडला थोडं नावं ठेवायला लागतं, आणि त्याच्यासाठी आपण ह्या मेथड्स पाहतो. Okay, so second method is called as a two-dimensional parity check code. So what we do here in two-dimensional parity check code is we arrange the data into a block code, and then we ensure that whatever the data that we have, we check the parity row wise also, and then we check the parity column wise also. So here just take any one example. Let us go for this. So here 0 1 1 0, so even number of ones are there, so parity will become 0. And for this line, let us go take example for this line 1 2 3 4 and 5. So total 5 number of ones are there, so the parity will become 1 because odd number is there. So that way we will calculate for each row and column, and then we will have the rows parity here and column parity. Then at last what we do, we go for checking the parity here also, like 1 1 1 and 1 1 1. So 3 3 are there, so we have here value equal to 1. Similarly, these are the few examples with, suppose with two-dimensional parity check, if we go for one error occur in the data transmission. ह्या ब्लॉक मध्ये समजा एकच कुठलं तर बिट मध्ये एरर आली. सो 1 बिट मध्ये एरर आली, समजा इथल्या 1 मध्ये इथला 1 0 झाला. If this one becomes 0, then column wise parity it will immediately get affected, because here only in this column only one will be present, and that which is an odd number, it should be equal to 1, but it will still remain equal to 0. So error will be detected. What does this mean? 1 bit error can easily detected in a block parity check. Similarly, if 2 number of bits get affected or 2 number of bits get changed, those also will be those error will also be detected in a block parity check. Similarly, if 3 number of errors will occur, that also will be checked, or the guarantee can be given for error finding for 3 number of error also in this kind of parity check method. But here, if 4 number of bit got changed, then the error cannot be detected. That means if we go for a two-dimensional parity check for a block of data, then 1 2 and 3, up to 3 number of bits, we can give a foolproof guarantee that error can be detected and it can be conveyed to the receiver side so that it can discard it. But if four number of errors will take place, this function fails, or this will not give any kind of guarantee of protection of your data for error mechanism or error checking. And that is why this will also fail for up to a limit of 3 bit error detection, but for 4 bit and onwards that it will fail. Is it clear now? So we have seen two kinds of parity methods check, like two kinds of error checking here. One is the simple parity check. Second is the multi-dimensional or a two-dimensional or a block parity check. Now let us go ahead with the last part of error check, which is nothing but cyclic redundancy checksum, which is also, or which is very popularly known as CRC error detection method. And based on this only, there will be problems asked in the examination. As far as exam is concerned, this is very important bit in which there will be some theory part, or if not, there will definitely be a problem asked on this CRC. Now, how does a CRC encoder and decoder works? So this is what the diagram for the CRC encoder and decoder. Now, thing is, unfortunately, this particular bit will take more time to get details of this, because the process is a bit complicated. So what I will do is I will share you the notes for this on your WhatsApp group immediately after this. You just read it and then you attend the next class tomorrow, so that it will become very easier for you. Because if I would have been here like in physical, if we would have discussed, this point could have been very easily clear, but this is a bit complicated. So I will share you the notes, you just go through it. I'll show you an YouTube video also, which is prepared by me only. So in that, I have taken few example for CRC. You just go through it for say 10 to 15 minutes. Once you go through it, once you understand that, then I'll tell you more details about this CRC encoder and decoder, so that the things will become much easy for you to understand this CRC mechanism, because it has to undergo certain calculations. It has to undergo a modulo division. So you need to know what exactly a modulo division is. So I will give you all those details. Just go through it once, and then you will definitely understand this very easily. Am I clear with this?
Okay, sir.
Okay. Okay. So I'll just stop the recording now.